And by the way, if you're thinking about those and you want to practice more, but you're not sure how, you can come and see me in my office, and I can either direct you to some good study materials, or I do have a couple websites that will just sort of make up problems for me, and I can give you a whole sheet of practice problems with answers on the back. And so you can go through 20 fraction problems if you want to, or later on when we get to exponents, you can go through 20 exponent problems on one sheet if you want to. All right, so first off, we're going to start talking about multiplication and division of real numbers, both positive and negative. We're going to just kind of go through this little illustration on multiplying numbers and what exactly we're doing. And this will maybe give us a better sort of intuitive understanding of why multiplying a positive by a negative gives us a negative, and why multiplying two negatives together also gives us a positive. So when we talk about multiplication, there's a few different ways that we can look at multiplication. When we say 3 times 5, one thing we say is with the multiplication sign in the middle, 3 times 5. Another way we can look at that is 5 repeated 3 times, right? The last kind of way that we can look at that is add 5 together 3 times, right? And so multiplication is sort of like this operation that's equivalent to repetitive adding, right? Multiplying 5 by 3 is the same thing as adding 5 together 3 times. All right, and so on this first line of the table, you can see 3 times 5, that is 5 added together 3 times. That gives us a positive 15. When I say 2 times 5, that says add positive 5 together 2 times. That gives me a positive 10. 1 times 5 is obviously just the 5. 0 times 5, clearly that's 0. But now if I say 1 times negative 5, kind of in the way that we've just been thinking about it, that's saying add negative 5 together with nothing. So that's what we've done in this line. But when we say 2 times negative 5, they say add negative 5 together twice, right? And so that's kind of one of the reasons why when we multiply by a negative, we end up with a negative as a result. Because what we're really saying is multiply that negative number together that many times. So that's kind of one way to sort of look at multiplication by negative numbers. So that leads us to the official rule that says the product of a negative number and a positive number is negative. And to find the result, we multiply their absolute values together and just make the result negative. All right, and so in this first example, they tell me to multiply 8 times negative 5. I know that the absolute values of these are just 8 and 5, right? 8 times 5 is 40. Since one of these has a negative sign, the end result is just negative. And that's really all you do. You multiply the two digits and then apply the negative sign as needed. So with this next one, I'm multiplying two fractions. One of them's negative, so the result will be negative. But when I multiply fractions, remember I go straight across the top, which is going to give me 1 times 5. And then I go straight across the bottom, which gives me 3 times 7. So that's 5 over 21. One of the numbers coming into this product was negative, so the result is negative. Okay, let's talk about also the multiplicative property of 0. 0 is an interesting one. 0 is the number that you multiply anything by 0 and it ends up back at 0. So 0 kind of pulls everything in, right? Anything multiplied by 0, you just get 0. It's the great equalizer. So in this first example, I've got 173 times negative 452 times 0. So the result is 0. Right? It doesn't matter what the other things are. If I have a 0 in there, the whole thing is 0. This example here, we can see there's a bunch of complicated stuff in here. I'm not sure what x or y equals, so I'm not sure what comes out on the other side. But if I just throw a 0 in here, all this stuff multiplied by 0, I can cancel out these question marks because I know the result is 0. So that is one of the benefits of 0. Okay, so now let's talk about the product of two negative numbers. So when we multiply two negative numbers, the result is positive. All right, so that's a little bit strange, but that's just the way it works. Two negatives equal a positive. One negative equals a negative. All right, so with this next example, we have 6 times 8, which is, what is 6 times 8? 64. I'll go with that. So we have 64. The rule says two negatives make a positive, so it's a... I trusted you.
48.
48.
See?
Well, it's closer than what I would have got, which was nothing. So 48, and it's positive. Okay? Oops. This next result. So we have two negatives going in. 1.2 times 3 gives us 3.6. The double negative makes it positive in the end. All right, this next example is a good one. So this one, we're going in with 3 negatives, right? So we're going to take this one step at a time. First, I'm going to calculate the result of multiplying these two things together. So I'm going to leave my negative 3 out front. And when I multiply the negative 2 and the negative 5 together, I get a positive 10. The negative 3 now multiplies it in and gives me a total result of a negative. And part D. I have 4 negative numbers that I am now multiplying together. So I will handle them a little bit separate. I'm going to multiply these first 2 together and then these second 2 together. So when I multiply the negative 4 and negative 6 together, I end up with 24. Then when I multiply the negative 1 and the negative 2, I end up with positive 2. So the total result is a positive 48. So these last 2 examples are important to illustrate something. Notice that when we had 3 negatives, a negative popped out the other side. But when we had 4, all the negatives canceled out. And so that leads to kind of a rule. When you have an odd number of negative symbols, the result will be negative. But when you have an even number of negative symbols, the result will be positive because they all end up canceling each other out. Okay. Okay, and then we have the opposite property of negative 1. This just says that negative 1 times anything gives us the opposite of that thing. We kind of already went over this, I think, in the last class period. Okay, moving on to division. Okay, so when it comes to division, we typically use, in this class, we do use the old school division symbol, but usually when we want 4 divided by 5, we write it as a fraction in this class. The fraction, a over b, this is the fraction that is defined as the number, if one exists, that when multiplied by b gives a. So that means that the number 3/4 is the number that when multiplied by 4 gives us 3. And we can see that's the case here, right? When I multiply 3/4, here highlighted in yellow, I'm actually multiplying it by 4 over 1, right? And then in the end, the 4's will cancel and we just get 3, okay? All right. Oh, let's see. Now, I can't remember which page this is on, but if you need a reminder as to sort of what's positive and what's negative when multiplying, this is in this chapter. You can really just sort of write it on the margins of your notes, though. It's easy to memorize after a while. Okay, so in some of these, they ask us to complete this division and check our answer, right? And so with this first example, 14 over negative 7, this is asking us to give them the number that when we multiply by negative, or we multiply this, they want us to give the number that when multiplied by negative 7 gives us 14. Okay? I know it's pretty wordy for fractions. If you don't actually have to think about all this stuff in this way, but it helps for the concept sometimes. So, okay. To do this, we can go ahead and simplify these fractions. So, what's that? Come on.
It's going to end up being 7, right?
It will end up being, let's see now.
Because if you simplify, it's going to go, 1 can go into 14, or 7 can go into 14.
Ah, careful though, right? There you go, yeah. So on top we have 2 times 7, right? That's equal to 14, and on the bottom we have a negative 7. Right, the 7s will cancel, and I'll end up with a negative 2. Yeah. Okay. And so they want to know, so they're saying check our answer as well. So they said that this number, 14 over negative 7, that should be the number that gives us 14. We multiply it by negative 7, and negative 2 times negative 7, right? The double negatives go away. That gives us a positive 14. So yeah, that one worked. All right, for the 32 over 4. When we have the double negatives, remember the rule is when you're dividing or multiplying by a double negative, they go away and give you positives. So we can simplify this, and on the next step, the negatives can just go away. Right, and so 32, let's see now, 32 divided by 4. Ah, thank you, 8. Okay, so 4 times 8 is 32, right? And so I will split off a factor of 4. We have matching negative 4s on the top and the bottom, and so we cancel those, and this gives us an 8 as a result. So they're saying, to check this, we would say, okay, when I multiply this number 8, when I multiply this number 8 by negative 4, does it give me negative 32? Well, over here I can say 8 times negative 4. Yeah, it does give me negative 32. Cha-ching, so we're good on that. Okay, once again, I have a 10 over a 2, so I'm going to simplify this. This is going to give me a negative 5 times 2 over 2. I can cancel my 2's. This will give me a negative 5 as a result. Okay, and so now I want to check this. I want to say, when I multiply negative 5 by 2, does it give me a negative 10? Yeah, it just does. I don't need to write it out for you. Okay, that leads us to the next part. Negative 17 over 0. So according to the rules of division, this is asking us to, this is saying this is a number that when we multiply by 0, it gives us negative 17. Is that possible? No, we just said anything multiplied by 0 gives us 0, so it's impossible for this to work out. That's why this is undefined. This is bad. This is bad. All right, so dividing by 0 is completely undefined in mathematics, and we cannot do it. Anytime you see something divided by 0, if you have divided by 0, back up and do something different. If a problem gives you something that's divided by 0, you can immediately say, whoa, there's no answer to this. All this is undefined, and just write undefined in big block letters with an exclamation point. Okay. So no dividing by 0. However, if 0 is in the numerator, it's just fine, right? And so 0 over 17, that's fine. But 17 over 0, that is bad. Okay, just a quick note, something that you might have seen me sort of doing up here. The negative sign in fractions can move around. And so we can, if we prefer to write it with the negative sign out front, we can do that. If we want to move the negative sign up top, we can do that. If we want to move it to the denominator, we can do that as well. And so those negative signs can shift around wherever we want them. So in these examples, they ask us to write they ask us to rewrite these in two equivalent forms. And so we do that by just shifting that negative sign around. Okay, so this 5 over negative 2, we can rewrite that as negative 5 over positive 2 if we want, or we can shift that negative sign all the way out front to give us negative 5 over 2 as a whole. All right, so all those are equivalent. Negative 3/10. Same deal. We can move the negative up top and attach it to the 3 if we want to, or we can move it down below and attach it to the 10 if we want to. The important part is that you never change the number of negative signs in there unless there's a reason for doing that, right? And so if you're going to shift the negative sign around, make sure it's just one negative sign, right? The one out front can't shift to top and bottom. It doesn't work like that. So that leads us to these types of problems that we're going to run into with sort of negative signs flying out on a single fraction, more than one negative sign on a single fraction. So to do that, we just sort of move it out front and deal with it. Right? And so if I move this negative sign out front, that means I have a double negative out here, which turns into a positive. Right? And so this double negative inside a single fraction cancels itself out. So this turns into 3/7 plus 5/7, which ends up giving us 8/7. All right, this next one, I have 3 negative signs attached to the same fraction. That's okay to do. You won't see it very often, but it's fine to do that. The way that I do that is I consider them all attached to one fraction, right? Negative 5 divided by negative 7, that cancels out those negatives. So I'm just going to go boop, boop. Those are gone. I'm going to say this is 3/7 minus 5/7 now. What does that give us? Negative 2/7, which we could write like that, or we could write it like this if we prefer, or, whoops, careful, or we could write it like this. Any way is fine. Personally, I prefer it with a negative sign out front, but I'm a weird person. All right, so let's do a few examples. All right, so in these examples, oops, it's weird. Okay, so in these examples, we are just kind of handling the negative signs. So on this first one, I'm going to multiply straight across the top and straight across the bottom. I'm just going to sort of ignore the negative signs for now so they don't get in the way. So I'm going to say 4 times 7 on the top. That gives me 28. And then I'm going to say 5 times 3 on the bottom. That gives me 15. Now I'm just going to notice I have 2 negative signs, which makes the result positive. I put a plus there, but you don't have to. All right, so the next one. This one is interesting. So just be careful. The plus sign here is a little bit misleading. Because there's a negative sign contained somewhere in the fraction, that sort of supersedes the plus sign, right? And so we move the negative sign from the 7 up in front of the fraction. So that's going to give us a negative 2 over 7 minus 9 over 7 more. So that gives us a total of negative 11 over 7. All right. Still moving, finding reciprocals. So, can anybody tell me what the reciprocal of negative, actually I should go over this first. Remember, reciprocal is the number, the reciprocal of negative 27 is the number that when I multiply it by negative 27, I get positive 1. It's important to remember the reciprocal gives you a positive, not a negative. So when I say, what number do I multiply by negative 27 in order to get positive 1, we have to make sure that number is a negative as well, right? 2 negatives give us a positive. So the reciprocal of negative 27 is negative 1 over 27. Remember, reciprocals, to find the reciprocal of any number, you just put 1 over that number and apply the negatives if you need to, right? So these two multiplied together would give me a positive 1. They want to know the reciprocal of negative 3/4. Well, that is negative 4/3. If we want the reciprocal of negative 1/5, that is negative 5 over 1, which is equal to negative 5. Does 0 have a reciprocal? Nah, right? Because we form reciprocals by saying 1 over that number. And if we said 1 over 0, we'd be breaking our own rule. Okay. All right, so when we talk about dividing two negative numbers, once again, remember to divide fractions. We flip the denominator and then multiply. So I leave my negatives there. I leave my first fraction as is, and then I flip my second one and multiply. So instead of negative 5/4, I have negative 4/5. Okay, when I go straight across the top, I end up with 8. When I go straight across the bottom, I end up with 15. Since these were both negative, the result is positive. All right, on this next one, it's division again. So I am going to flip it, right? Remember, division is equivalent to multiplying by the reciprocal. So the first number stays the same, negative 3/4, and the second number flips, and I change this to multiplication. So now I have 10/3 instead of 3/10. Okay, now in this step, before we even multiply through here, if we want to cancel something on this step, it's completely valid to do that. You can see I have a 3 on the top and a 3 on the bottom here, so I'm just going to cancel those before I do my multiplication. If you prefer to cancel afterwards, that's totally fine too, but it's valid to cancel on this step if you want to. So I'm going to cancel my 3's and move on. So now I have 10 over 4. I only had one negative sign coming into this, so my result must be negative. All right, and now 10 over 4, those are two even numbers, so I'm pretty sure I can simplify that. I'm going to rewrite this as negative 2 times 5, which is equal to 10, and then 2 times 2 on the bottom, which was equal to 4. I cancel 2's, and I end up with negative 5/2. All right, this one here I'm going to do on my calculator. 27.9 divided by 3. This is equal to 9.3. I had one negative going into this, so my result is negative. Okay, any questions about those? I think we pretty much beat that horse to death, right? Okay. All right, so just a few more reminders on dividing by 0, because that is one that we tend to forget as we go through. So just remember, any number a over 0 is undefined. If you come to an answer that has something over 0, you can just write undefined and put a box around that. That's totally fine. However, if a is not equal to 0, then any number 0 over a is just equal to 0. I pulled up a couple of memes on what happens when you divide by 0. This is a true story. This kid divided by 0 and his house went up in flames. It's unfortunate. He had a parakeet that didn't make it. His name was Timmy. Okay. This is another true story about what happens when you divide by 0. The Earth could get hit with a meteor. Some people think that's what happened to the dinosaurs. They think they were on the verge of learning algebra. Somebody divided by 0, and everything went to crap. Here is just something to help you remember, right? Divide by 0, N-O, right? N over 0. 0 divided by something else? Okay. All right. Yeah, there's a lot of jokes out there about dividing by 0. Yeah, Look them up if you feel like being entertained. All right, so that was chapter 7. Now we get into chapter, that was chapter 1.7. Now we get into chapter 1.8. 1.8 is sort of our first real introduction to exponents. Exponents are huge in this class, and sort of, it really helps just to get used to these, just like a bunch of other things that I keep saying this about. Exponents are definitely everywhere, though. All right, so let's kind of get into sort of an intuitive notion of what an exponent is. So when we use the multiplication symbol, we use it in a certain way, right? We don't typically standardize it like this, but they say, like, you could say that this is kind of like the base, and this is a little bit like the exponent. And so with this first one, they say multiply this number together, this many times. Sorry, add this number together, this many times. Well, that's the notation when we add things together a bunch of times, right? But we also have a notation for when we multiply things together a bunch of times, right? And so this is 3 added together 4 times. But what happens when we multiply 3 together 4 times? Well, for that, we use exponential and power notations. So instead of writing 3 times 4, like they did with the addition, right? When we multiply a bunch of stuff together, we write it like this. All right, the 4, the number of times that thing is being multiplied together, that goes up here. We call that the exponent. Whatever the thing is that's being multiplied together, that's called the base. That goes down below. The exponent should be a little bit smaller, or well, a lot smaller, really. Okay, so imagine they tried to get us to put this into exponential notation. So we have 1, 2, 3, 4, 5 copies of 10 multiplied together. All right, 10 is the number being multiplied together, so that's the base. We write that down here. The number of times that 10 gets multiplied together, that's the exponent. That goes up top, right up here. All right, so if they ask us to do this in reverse and simplify these, this number, 5 squared, that just means 5 times 5, and that equals 25. So be really careful. One of the most common mistakes with exponents is to turn this into just multiplication. People will say, well, that equals 10. It's a really common one because your brain wants to just multiply those 2 numbers, but be careful. It's not 10. It's 5 times 5. All right? This one here. When you see the brackets around some stuff and there's an exponent on the outside, you multiply together everything in the brackets. Right? And so we have a negative sign in our brackets here. So we multiply in brackets -5 times -5 times -5. Right? That's equal to 125 if you multiply all the 5s together. We had 3 negative signs going in, so the result has to be negative. All right, we do the same thing. We have -5 squared. I write -5 times -5. The result is 25. The double negatives cancel out, so the answer is positive 25. And the same exact thing happens when we have a variable in here. So I put it in brackets, 2n times 2n times 2n. Because of the commutation rule, we're allowed to organize these things however we want. So I'm going to put all the 2's together in front. I have 2 times 2 times 2, and all the n's together in the rear. I have times n times n times n, right? 2 times 2 times 2, that gives me 8. N times n times n, that gives me n cubed. Okay, so officially, The exponent notation says this. B to the n means b multiplied together n times. Okay, so now that we have talked a little bit about exponents, let's talk about order of operations. Order of operations are kind of a pain, but extremely important. Because everything in math has to be exact, right? We cannot give you two of the same problem and have two different answers be correct. So we have to use some really rigorous rules on what comes first, what comes second, what comes third, and so forth. That is what the order of operations is all about. So on page 61, we have a little box for the order of operations. It's pretty helpful. If any of you guys remember PEMDAS, does that sound familiar? PEMDAS? Yeah, I see some people nodding. So,
Yeah, that's
what's that?
Please excuse my dear and son. Yeah. Please excuse Francis.
Oh yeah, okay. Yeah, see, so yeah, some people have got some different, what is that, a mnemonic? Isn't that what they call that? So, PEMDAS. PEMDAS. So P, and this is just something to help you remember what order everything comes in. So P is for I don't know if I'm spelling any of this right. So P is for parentheses. E is for exponents. M is for multiplication. Vertical writing is really uncomfortable. D is for division. A is for adding. S is for subtract. Excuse me. So, if you take a look at the rules that are on page 61, you'll see that they match up with PEMDAS exactly. Something with PEMDAS that a lot of people mistake, there's a common error with this, and people use Facebook memes a lot to kind of tease it out. A lot of people think that multiplication and division are two different steps. When you do PEMDAS, you handle multiplication and division on the same step. So whatever comes first, left to right, you do that. The same is true with addition and subtraction. Sorry. Excuse me. Having a little bit of difficulty today. Okay, so let's tackle some order of operations problems. So on this one here, example A, first of all, what's that? Oh, no, thank you. I might grab one in just a couple of minutes, though. That was a little weird. So on example A here, first, we just go through our PEMDAS, right? And so we say P stands for parentheses. We go from left to right. There's no parentheses. E is for exponents. So we go from left to right. There's no exponents. Now we do multiplication and division on the same step. There is a multiplication and division step. So 15 stays the same because it was not multiplied or divided. The subtraction stays there, and now we complete this little multiplication here. So we replace the 2 times 5 with 10, and then we have a plus 3. All right. Now that we've done that, we can go to the last step, which is addition and subtraction. So we go across handling that. So I have 15 minus 10. That gives me a 5 plus 3 is 8. Okay, so for this one, B, we have 3 times 4 in parentheses squared. So PEMDAS says handle anything in the parentheses first, right? So we go all the way into our innermost parentheses, which is our only parentheses in this problem, and we handle everything in here first before we do anything else. So now I go through, right? I'm in the parentheses. So now I say, are there any exponents inside those parentheses? No. Okay, move on. Multiplication and division. Yes, we do have that, so we can complete that step. So 3 times 4 turns into 12. I have that squared. Okay. Now inside the parentheses, there's no more addition or anything else left. So I'm done inside the parentheses. Now I handle the outside of the parentheses. This is a bad example for this one. So now on the outside of the parentheses, I only have the exponent left, so I can just square this and really call it a day. So this is equal to 144. Yeah. Okay, here's something important. These two examples are slightly different. The difference is there are no parentheses on part C. The parentheses are really important. If there are no parentheses, then this little exponent in this lower example, it only belongs to the 4 and not the 3, right? So let's go through our order of operations. So we have P first. There's no parentheses. Okay. Move on. Then we have exponents. Okay, so now we should handle this little exponent on the next step. So I have 3 times 4 squared. That gives me 16. Now I do multiplication and division, and this will end up giving me 48. Right, and so you can see when I had the parentheses in there, I ended up with 144. When I didn't, I only ended up with 48. And so there's a big difference, right? If the exponent is outside of parentheses, then it's everything on the inside of parentheses that gets hit with the exponent. But if there's no parentheses, it's only what the exponent is attached to. Okay, let's keep moving here. Okay. Sorry, that's a bunch of junk. You guys don't need to see all that, I don't think. Oh, I should go over this real quick. So before this next example, this is just kind of an example of why those parentheses mean so much. So this first line here, we can see we have a -5 squared without parentheses, right? That means that the square is only attached to the 5 and not the negative, because there's no parentheses. So this means it's -1 times 5 squared, which gives us an overall result of -25. But when we have the parentheses around the negative, that means that the square is attached to the negative as well, right? And so the square moves out to the negative and squares the -1, and it squares the 5, giving us a result of +25, right? So parentheses matter a lot. And if there's no parentheses, that exponent is only attached to what it's attached to. So, for an example, suppose we want to evaluate these expressions for x equals +5. For this one, we just replace the x with +5. Since it's just a +5, we don't really need parentheses around what we're replacing. So I'm going to write all this out. I have negative. I replace the x with 5, and then we square it. Okay? This is just equal to -5 times -5, which is equal to a +25. We're sort of just redoing what we just showed you. So on this next one, once again, I'm going to plug in x equals 5 for my x, and you can see when I don't have the parentheses around the negative, I just leave it out there. So I have -5 squared. Okay, that is equal to a -1 times 5 times 5. That's equal to -25. All right, so that's the illustration of that. So now that we've kind of seen what that does, let's move on to some more order of operations problems. All right, so this problem, they've asked us to evaluate for a equals 4. So on the first step, I'm just going to take this one step at a time here, and on the first step, I'm going to replace a with 4. So I have negative 15 divided by 3 on the outside, 6 minus a, and a is equal to 4. All right, so we're asked to evaluate this stuff. We're asked to calculate what's going on here. So I use my PEMDAS. So I say P, right? P says we handle anything in parentheses first, okay? So I handle everything in these parentheses before I do anything else. All right, inside those parentheses, the only thing we have to do is subtract, so we're just going to do that on this next step. And with these problems, a lot of times I like to just do one small thing per step, and that way you don't get jumbled up too bad. So that leaves me with a negative 15 divided by 3 times 6 minus 4 is 2, so now I have 2 cubed. Okay, so now I'm done with those parentheses, right? Even though I guess they're still there, but they don't really count anymore because I just have a 2 inside them. So now I start over. I do my PEMDAS again. So P, no. E, yes. I have an exponent. Let's handle that next. So negative 15 divided by 3 times 2 cubed, that's 8. All right, so now I'm getting down to the last bits here. I run through my PEMDAS again. I just did my exponents, so now I do multiplication and division on the same step. All right, so first, since division comes first, left to right, I divide negative 15 by 3. That gives me negative 5. And it's still multiplied by 8 here. Only one thing left to do, right? Yeah, the result is negative 40. All right. If these are looking really confusing, that's okay. Order of operations, like they build these to look confusing. So if you're thinking, that's ugly, it should look ugly. They're supposed to. These guys are professionals. But these are the perfect kind of problem to come by my office and have me print out, a list of 15 of them for you to just kind of run through and see if you get the right answer on it. And if you don't, come ask me what happened, and we can work on it. But yeah, these ones are good to practice. Okay. This is a good long one. So once again, we use our PEMDAS. First thing we do is parentheses. An interesting thing I note about this problem is that we have nested parentheses, right? We have these square brackets here, but we also have brackets on the inside of those square brackets, these round brackets. When you're dealing with multiple sets of brackets, deal with the innermost one first. It's like reverse onion, right? You go from the inside out. All right, so first I'm going to handle everything in this bit of parentheses inside the larger square brackets. So I have 8 divided by 4 plus 3 times 9 plus 2 times, let's see now, 3 minus 5, that is negative 2. So I'm going to put it in parentheses, negative 2 cubed. All right. So I handled what was inside that innermost bit of parentheses. Now I have to move out and do my order of operations again on this bit of parentheses, on all this stuff in the blue. So the next thing I do in here, I go through, I have an exponent. We know that we have to handle those before we do multiplication and division, so that's what I'm going to do. So I have 8 divided by 4 plus 3 times 9 plus negative 2 cubed. What is that? What is it? Positive or negative? Negative. Good, yeah, it's cubed, right? So there's 3 lined up. That means the result is negative, which means I have 2 times a negative 8 here. Okay, next step. This is going to take forever. Next step. So I have 8 divided by 4 And believe me, when you start to get used to this, like these problems don't take that long. I have to do every step up here, and that's why some of you might be bored out of your mind right now. So, okay, so now I'm still working on the square brackets. I want to go through and handle all my multiplication on this next step. I only have one multiplication to do, and it's right there. So I have 9 plus 2 times negative 8. That gives me, oops, I should erase this plus sign. That gives me negative 16. All right, we're getting there. We're getting there. So now I have 8 divided by 4 plus 3. Now I handle my last bit of math inside the parentheses. 9 minus 16 gives me a negative 7. Thank you very much. Negative 7. Okay. So now, almost there. I'm out of the parentheses. I'm in the whole, I'm in the outer world now. And I just go through and I handle my division and my multiplication on the same step. So I handle this and this. 8 divided by 4, that gives me 2. Plus 3 times negative 7. Oops, that should be a negative. That's minus 21. And finally, I get a negative 19 as a result. I don't necessarily need to see all those steps when you do your order of operations. I tend to, I want to go through like all this junk in detail when I do this the first few times, but I definitely want to see, you don't have to do one tiny little step, but if you have an order of operations problem like this, you should definitely have at least 2 or 3 steps in it. After you get used to this stuff, you're not going to say PEMDAS anymore. You're just going to do it. It's weird. It kind of becomes instinct after a while. All right, let's do another example. This is a good one. So, yeah, right. So, so when we have a fraction sign, we just we consider this barrier, the fraction symbol, to be like it auto-assigns brackets almost, right? And so if there's no brackets, like you just kind of imagine that there are brackets because of that fraction symbol. Right? And so we handle those two separately, and then we put them together. So what I like to do when I'm doing order of operations on fractions, because they're both in brackets, and they're both at sort of the same level of bracket, I do one step on the top and one step on the bottom for each step in the equation, if that makes sense. So I say, what can I do on the top? Well, first, I need to handle everything in the parentheses on the top. So that's all I'm going to do on the first step. So I'm going to say 12 times 9 minus 7 is 2. Okay. And then plus 4 times 5. Okay, so that all stays the same. On the bottom, everything's with exponents, so I can do that for the first step, right? So 2 to the 4th, that is 16. 3 squared, that is 9. All right, so I just did one step in the numerator and one step in the denominator. So now I'm going to keep on going. In the numerator, I don't have any exponents, I don't have any parentheses, I have 2 instances of multiplication, so I'm going to do that on the next step. 12 times 2 is 24, plus 4 times 5, which is 20, and that's all over 16 plus 9, which is 25. All right, so now I only have one step left to do on the top, which is addition. That's going to give me 44 over 25. And those don't share any common factors, so we're done. Okay, so those aren't too bad. You just you simplify simplify everything you can in the numerator and the denominator, and then you sort of put it all together in the last step and simplify that last step if you can, but we couldn't. All right. Keep going. Okay, so this is a good one. When it comes to order of operations or any problem, if I ask you or if anybody asks you to simplify it, that means that there should not be any brackets like this. Right? We have 2 multiplied into this sum, which is not simplified. If we ask you to simplify something, those should be completely gone. Okay, so for this particular one, if I asked you to simplify this, you would distribute that 2 in. So you'd say 5x minus 9 plus 2 times 4x, that gives us 8x, and then 2 times 1, that gives us a plus 2. Now to fully simplify this, you'd put together any like terms. I have x's here, and I have just constants here. So I'd put all those together. So 5 plus 8, that gives me 13x. And then 2 minus 9, that gives me a negative 7. Okay, so we just put together some like terms, and those had a single factor of x, right? 5x and 8x. Something that we will see in this next example is that those have to be the exact, not only do they have to have instances of x, but it has to be the same number of instances of x. And so x squared is not a like term with x cubed, because those have different numbers of factors of x's. All right, so this example will illustrate that. So I'm asked to simplify this. I know that to simplify this, I have to get rid of those parentheses and combine any like terms. So I write down my 7x squared, and then I distribute my 3 into both of these terms. So I have plus 3 times x squared gives me 3x squared. 3 times 2x gives me 6x. And then I have a negative 5x hanging out here. So these two terms, these first two terms with the squares, those are two like terms, and these ones here with a single x are like terms. But you can't put them all together, right? The x is not the only thing that matters. It matters how many copies of x are in there as well. So I have 7 plus 3x squared. That gives me 10x squared. And then I have 6 minus 5x. That gives me a single x. So I have plus x here. All right. And on a side note, could we factor this if we wanted to? Could we factor something out of this? This is a little unrelated and maybe what we did earlier this week. Yeah, we kind of can, right? We know it's got a common factor. What can we factor out of this? I'll show you. I think you got it. I think I see somebody saying yes. Okay, so, right, we know that each of these contains at least one factor of x, right? This contains exactly 1. This contains 2. So we can rewrite this. So I can say, well, this is x times 10x, this first term, and then the second term is just x. But it's also multiplied by a little 1 here, right? And so we'd say, oh, both of these contain factors of x. I'm going to pull that out front. So we would write the factor out front, and then in parentheses, we'd write whatever's left. 10x plus 1. Okay, so that's just a little recall from some factoring. All right, moving on. Aha, the opposite of a sum. So remember, when we were talking about opposites, I said if somebody gives you a long list of stuff and they say, give me the opposite of that stuff, all you got to do is put brackets around it and throw a negative sign out front. And that's it. That's the opposite. However, that's not really the simplified opposite. You know, it's not really in proper form. In order to like fully put the opposite, you have to distribute. You have to distribute that negative into each term, right? And so this here is the opposite of 3x plus 2y plus 4. But unless you're kind of being like a lazy mathematician, which is okay if that's all I ask for, but if I ask you for something a little bit more, if I ask you to simplify things, which you always should on an exam, then you just want to distribute that negative. So in order to distribute a negative, you just change the signs of everything inside. Notice how everything in here is positive right now. Now I just distribute this negative. So this becomes a negative 3x, a negative 2y, and a negative 4. Okay, so when you have a negative out in front of parentheses, change the signs of everything on the inside. All right, and that's the same thing as this official rule that just says the opposite of a sum, AB, is just negative A, negative B. Okay, so on your homework, when you're given a problem like this and they say simplify this, in order to get rid of this negative sign in these parentheses, you just have to distribute it in. And so this becomes 3x, the 4x becomes a negative 4x, and the positive 2 becomes a negative 2, and then that's it. And then we combine like terms if we can. I have 3x minus 4x. That gives me a negative x minus 2. All right, we'll do some more examples. Let's see now. Okay, good. Yeah, we got some more examples to do. So actually this one, well, we only have 9 minutes, so I guess I won't make you do problems on your own today. All right, so let's just keep going. So for this one, once again, I'm asked to simplify this, which means I got to drop all the parentheses and try and combine like terms. I have a negative sign out in front of my parentheses, so I got to apply that. So my 5t squared drops straight down, so does my negative 2t. My negative sign now distributes in. I have a negative 1 times a negative 4t squared. That is 2 negatives, which gives me a positive. Then I distribute my negative sign into the last term, and that gives me a negative 9t instead of a positive 9t. Now I got to combine like terms if I can. These two have variable factors of t squared. These two have variable factors of a single t. So 5t squared plus 4t squared, that gives me 9t squared. And negative 2t minus 9 more t, that gives me negative 11t. All right, let's keep going. This one here, we have a negative 2 out front of the parentheses instead of just a negative 1. It's the same thing. We just multiply it by a negative 2 instead of a negative 1. So the 3n drops straight down. Now we distribute the negative 2 in. Negative 2 times 4n gives me negative 8n. Oops, that's not an n. Negative 8n. And then negative 2 times negative 5 gives me a positive 10. Now, I just need to combine my terms with a single n factor. So that gives me negative 5n plus 10. Okay, last one. Suppose I'm asked to simplify this big ugly guy. Right, this is super ugly. Once again, we're asked to simplify ugly things. We still use our PEMDAS and just try and do it as best we can like that. So PEMDAS says handle anything inside the innermost parentheses first. Right, P comes first. This is the innermost parentheses. Right, and so we say, okay, are there any operations we can do in there? No, not really. Nothing can combine in there. We can't do anything with the exponent because it's just on a variable, so we're going to move on to the next step. All right, so we consider the next set of parentheses, which is these ones, the square ones. Right, and so we can do some stuff in there. It says first we need to handle multiplication. Right, since there are no exponents to handle, we go multiplication first. So I have 7x cubed plus 2 minus, in square brackets. Now I'm going to distribute this to get rid of the round brackets. So I have 5 times x cubed, 5 times negative 1, and the plus 8 just hangs out over there. All right. Now I handle everything in those parentheses. We want to keep on going. I can combine the negative 5 and the 8. So I have 7x cubed plus 2 leave my negative on the outside. I have 5x cubed on the inside, and 8 minus 5 gives me plus 3. All right, almost there. So now I need to free all this stuff up from the parentheses, so I got to apply this little negative sign. So 7x cubed plus 2. Now I have negative 1 times 5x cubed. That gives me negative 5x cubed. Negative 1 times a positive 3, negative 3. Now I just combine everything. These ones have 3 factors of x attached. So I have 7 minus 5, that gives me 2x cubed. And then just my constant terms, I have 2 and a negative 3. That just gives me a negative 1 result. Okay, any questions about that? Yeah, and just remember, like, you know, this stuff can look really confusing. Sometimes you can get writer's block with it. Just be like, I don't know where to start. It all looks ugly. But, you know, I can really help you out if you just come to the office and I can give you a couple worksheets. Or, do I have something on my face? Lillian was in the back. I look at Lillian and she's like, I think it was just a tick, but I was totally like, uh-oh. Okay, so thank you for your patience, everyone. Please have a great night, and we will see you tomorrow.